Hello viewers, so welcome to my channel. I'm Hasham. So now I'm continuing the problems on network analysis. So far 11 problems I have completed in this video. 12th problem I am going to explain. So all the problems are based on the concept of network. So before watching the video on problems, I suggest you be perfect about the concept. What do you mean by network? What is a project? What are activities, events? What is critical path? Without knowing this, directly you should not come to the problem. So if you have not watched, I suggest you go to the playlist of my channel. Select the subject, Operation Research. Select the videos of network analysis. Be perfect about the concept. Watch the starting videos, first, second video. Then only you can be able to understand the complete problems of network analysis. So in this video, I'm going to start 12th problem. Before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready. Take the screenshot of the points which I have written on the board, then I'll explain every point in detail. Now, see the 12th problem. A project has the following characteristics. Activities are given A, B, C, D up to I. Immediate predecessor are given. Then time days. Most optimistic, most likely, most pessimistic. 3 time estimates are given for every activity. We have to combine the 3 activity times and make it one expected time, TE. In the previous videos, I've explained you the formula for calculating TE values. Here also I am explaining TO plus 4TM plus TP divided by 6. TO optimistic time, TM most likely time, TP pessimistic time, right? So we have to convert these 3 time estimates into one expected. Construct an arrow diagram for this problem. Network diagram we have to make. Determine the critical path and compute the expected completion time. For finding the critical path, we need EST and LFT values. And determine the probability of completing the project in 55 days. So, first of all, we have to find out the TE values and variance. So, first column, activity, predecessor activity, TO, TM, TP, expected time, this we have to find out. Then variance we have to calculate. Once we calculate this expected time and variance, we are not concerned with these time estimates. TO, TM, TP, we don't require. Only the thing is we need this one. So how to find out TO plus 4TM plus TP. So multiply TM with 4. So 6 into 4. 6 4s are 24. Plus 4 plus 8 divided by 6. You will get 6. Similarly, second, 7 into 4, 7 4s are 28. 28 plus 5 plus 15 divided by 6, you will get 8. Third one, finally, 8 into 4, 32, plus 4 plus 12 divided by 6, you will get 8. Like this, we have to calculate all the TE values. Now, variance. We need variance whenever we are required to find out the probability. In this problem, it is asking you, what is the probability that the project will be completed in 55 days? That's why we need variance, right? The formula for variance is TP minus TO divided by 6 whole square here. Pessimistic time minus optimistic time divided by 6 whole square. So for every activity we have TPTO. So 8 minus 4 divided by 6 whole square, you will get 0.44. Confirm it. Take the calculator. When I'm explaining, immediately type it on the calculator and find out whether you are getting the same value or not. So here 15 minus 5 divided by 6 whole square into is equal to 2.78. Similarly, 12 minus 4 divided by 6 whole square is equal to 1.68. We got all the variance values. So we have calculated expected time. Now we have to draw the arrow diagram or network diagram. Now see here, by seeing these activities and predecessor activity, we can be able to make the network diagram. What is the immediate predecessor for A activity? Nil. No activity is there for A activity. No predecessor activity is there for A activity. That means A activity is the first activity, no predecessor for A. So I am drawing from here 1 to 2. This is the A activity. Activity name is A. So on the arrow mark I am writing A. That is going from first event to second event. Right? Now B and C follows after A. That means A is the predecessor for B and C activity. So B and C are busting after A. So after A, B and C, these two activities are busting out. Right? Now we got A, B, C activity completed. Now D follows after B and E follows after B. So after B, two activities are busting, that is D and E. So here after B, two activities D and E. So D I am taking it down and B I am taking it forward. Why I am taking it D downward? Because F follows after C. F follows after C and H follows after DF. H follows after DF. That means D and F should combine. So here F follows after C and DF will combine here. So after DF, which activity is following? H. H follows after DF. After DF. E follows after B. Already we have written here. E follows after B. Now G follows after E. Now see here. G is the activity. The predecessor is E. So G follows after E. E completed, G follows. Now G and H I am combining because GH is the predecessor for I activity. GH is the predecessor for I activity. I follows after GH. So GH is combining and I follows. That's it. So from A to I, all activities. Remember, you cannot calculate EST, LFT values. You cannot find out critical path until and unless you have the perfection in drawing the network diagram. If you correctly draw the diagram, then only the remaining parts will depend. Otherwise, no, you cannot calculate anything. So have good practice on drawing this network diagram. Network diagram. You have to see which activity follows which activity, which is the predecessor and which is the successor activity. That you must know. So here I have explained. No predecessor for A. A activity, there is no predecessor for A. B follows after A and C follows after A. So B and C are following after A. Right? Then F follows after C. After C, F follows. Then D and E follows after B. After completing B, D and E are following. I have joined this D and F because DF is the predecessor for H activity. And G follows after E. And G and H I am combining because I activity follows after GH. That's it. So we have constructed the diagram. Now we have to calculate the EST and LFT values. The forward pass, EST value, backward pass, LFT value. Forward pass means going from first event to the last event. First event. The EST of the first event is always 0. This is EST value and this is LFT value. This LFT value will get afterwards, backward pass. First we calculate EST value. First EST of event 1 is 0. How many activities are merging here? Only one. So 0 plus 6 is 6. Don't see the second number. Second number is LFT. Afterwards, coming backward. First forward, first number. So 0. Here one arrow is busting. 6 plus 8, 14. Right? Then here one arrow is merging. So 6 plus 8, 14. Here one arrow is merging. So 14 plus 18, you will get 32. Here two arrows are merging. So we take the maximum. 14 plus 20 is 34. or 14 plus 10 is 24. 34 or 24, whichever is higher. 34 is higher, I have taken. Here two arrows are merging. So again we take the maximum. How much is 32 plus 8? 40. Or 34 plus 2, 36. 40 or 36, whichever is higher. 40 is higher. Then only one arrow is merging. 40 plus 7, 47. So we have calculated all EST values from first event to the last event. Now LFT value, we have to go backward pass. The EST and LFT of the last event will be same. So 47, 47. How many arrows are busting here? Only one arrow. So 47 minus 7. Forward pass, we are adding the duration. Backward pass, we subtract the duration. So 47 minus 7 is 40. Here only one arrow is busting. So 40 minus 2, 38. Only one arrow busting. 40 minus 8, 32. Right? Here only one arrow busting. 32 minus 80. No, two arrows are busting. Sorry. Two arrows are busting here. So we take the minimum. So 32 minus 18 is 14, or 38 minus 20 is 18. So 18 or 14, whichever is less. So 14 is less. Here one arrow is busting. 38 minus 10 is 28. Right? Now here two arrows are busting. So we take the minimum. 14 minus 8 is 6. Or 28 minus 8 is 20. So 20 or 6, whichever is less. 6 is less. Now 6 minus 6 is 0. Always you should get 0 LFT value in the first event. So if you correctly calculate EST LFT, you will get 0. If you commit any mistake, you may not get 0. That means your calculations are wrong. That's all. So we have calculated EST LFT value. Now critical path is the longest path from the first event to the last event, where EST LFT values should be same. Here, from here to here, it is only one activity. Now here you can see we can go either 2 to 3 or 2 to 4. But 2 to 4 you can see 14, 28. It is not same. So this is not the critical path. Now move upward. 14, 14 same critical path. From here we cannot come down because 34, 38 both are different, not a critical path. We move forward 32, 32 same. From here 40, 40. From here 47, 47. The critical path is shown by double lines where EST LFT values are same. 0, 0, 6, 6, 14, 14, 32, 40, 47. Double line it will be shown. That's it. So the critical path is 1 to 2, first event to second event, 2 to 3, 3 to 5, 5 to 7, 7 to 8. And critical activities are A, B, E, G, I. Duration of the project add up. 6 plus 8 plus 18 plus 8 plus 7. You will get 47 days. So duration of the project is 47 days. In 47 days we will finish off the project. Variance of the project duration. For variance, we add up the variances of critical activities. Don't take all the variances. Variances of critical activity. The critical activities are A. What is the variance for A? 0.44. We have taken 0.4. B. Next one is B. 2.78. We have taken 2.7. Then E. E is 7.11. 7.11. Then G. G is 1.78. Taken 1.78. Last I 0.11. That's it. Add up all variances, you will get 12.22 variance. Variance is the square of standard deviation. Standard deviation square is called variance. If you want standard deviation, put the variance under root. The variance root is called standard deviation. So standard deviation is equal to 12.22 root. You will get 3.5. So we got standard deviation. Why we need standard deviation? If you are required to calculate the probability. In this problem, it is asking you to calculate the probability. What is the probability that the project will be completed in 55 days? See here, on an average, the expected duration of the project is 47 days. But don't think that exactly in 47 days will complete the project. It will take more than 47 or less than 47, on an average 47. Now it is asking you what is the probability that the project will be completed in 55 days, right? So thus the project duration being normally distributed, we assume that project duration is normally distributed with mean mu is equal to 47 days and standard deviation is equal to 3.5 days. The probability of the project being completed in 55 days would be equal to the area under normal curve lying to the right of x is equal to 55. We have normal area curve. You might have already known that this is the normal area. This is a bell-shaped curve, normal area curve. In this, the total area under normal curve is 1. 0.5 area left side, 0.5 area right side. Complete, it is symmetrical. 0.5, 0.5. Now our mu value is 47 days. Mu is equal to 47 days where z is equal to 0 in the center. Now we need what is the probability that the project is completed in 55 days. So 55 is more than 47. So right side, this is 47. This is 55. Now we need what is the value of z. Our required area is completely this area. This area we need. Here we already know 0.5 is the area, right? 0.5 is the left side. Now right side we want the area from z is equal to 0 to z is equal to. What is the formula for z? X minus mu divided by sigma. X is the new duration. How much duration? 55 days. So in place of x, 55 days. Mu already we have calculated 47. Standard deviation calculated 3.5. So 55 minus 47 divided by 3.5, you get 2.29. So z value is 2.29. When x is equal to 55, z is equal to 2.29. Now, from the normal area table, that area between z is equal to 0 to z is equal to 2.29 is 0.4890. This area is 0.4890. From where do you get this value? From the normal area curve. See here, in any textbook you will get the normal area table. In any textbook, or you can go to the net and find out the values of normal area, z values. So how to locate that value? Z is equal to 2.29. So in the row 2.2, under column 9, you search. 2.2 is here. The 2.2 row under column 9. So 2.2 under 9 is 0.4890. So here it is given 0.4890, 2.29. 2.2 row and column is 9. We'll get the value, Z value, area value, 0.4849. Now we need the total area, shaded area. So this 0.5 plus 0.4890, 0.5 plus 0.4890, 0.9890. So probability that the project will be completed in 55 days is 98.90%. This is the probability. That's all. First attempt itself, you may not understand the technique of finding the probability. Watch the video twice, thrice. Follow my words. Then refer the table value. Definitely you can be able to understand. So this is the end of problem number 12. Now we will start problem number 13. See the 13th problem carefully. For the project data given below, find the critical path and its duration. It's a very simple problem. Only two things we have to calculate: critical path and duration. So for calculating critical path, we need the EST and lefty values. But before that, we must know how to draw the diagram, arrow diagram. So here activities are given 1 to 2, 1 to 4. So two activities are bursting from the event 1. So 1 to 2 and 1 to 4. Then 2 to 3, 3 to 4. Then 3 to 5, 4 to 6, 5 to 6, 6 to 7. And the durations are given. The first activity 1 to 2. So here you can see 1 to 2. I have taken 1 to 2. Then 1 to 4. So here I have taken from 1 to 4. So 2 activities, 1 to 2 and 1 to 4. Then 2 to 3, 3 to 4. So 2 to 3, right? And 3 to 4, from 3 to 4. So joining, one is coming from 1 to 4, another is coming from 3 to 4. Merging event. Then 3 to 5, this is 3 to 5. Then next one, 4 to 6, 5 to 6. This is 6th event. Then 4 to 6, this is 4 to 6 and this is 5 to 6. Last one is 6 to 7. This is 6 to 7. That's it. So you need a lot of practice in drawing this diagram. Without seeing the solution, you must try to draw yourself. Then only you can be able to learn. Now, durations are given 1 to 2. The duration is 3. So here on the activity I have written 3. Then 1 to 4 is 5. 1 to 4 is 5. 2 to 3 is 8. And 3 to 4 is 2. 3 to 4 is 2. 3 to 5, 6. Here I have taken. 4 to 6 is 8. 4 to 6 is 8. Then 5 to 6 is 7. 5 to 6, 7. And 6 to 7 is 9. 6 to 7 is 9. So after taking the duration, we have to first of all calculate the EST value from first event to the last event. Forward pass. Add all the durations. If only one activity is merging, add up. If two or more than two activities are merging in the event, take the maximum while going forward. So here only one activity is merging. 0 plus 3 is 3. Here also only one activity is merging. 0 plus 5 is, no, two activities are merging. Here only one activity is merging. So 3 plus 8 is 11, right? But here two activities are merging. So we need the maximum. 0 plus 5 is 5. Or 11 plus 2 is 13. So whichever is higher, maximum. 13 is maximum. Now here only one arrow is merging. 11 plus 6, 17. Here two arrows are merging. So again we need the maximum. 17 plus 7, 24. Or 13 plus 8, 21. 24 or 21, whichever is higher. 24 is higher. Only one arrow is merging. Add up. 24 plus 9, 31. How 31? 24 plus 9, 33. It is 33, not 31. 24 plus 9, 33 is there. Not 31. There is a mistake here. 33. Right? Now, 33 minus 9. 33 minus 9, you will get 24. 33 minus 9 is 24. Then 24 minus 8. So we can confirm it. 24 plus 9 is equal to 33. 33 minus 9 is 24. Now 24, here only one arrow is busting. 24 minus 7, you will get 17. Here 24 minus 8, 24 minus 8, it is 16. Right? Correct. Here two arrows are busting. So we need the minimum. 17 minus 6 is 11. Or 16 minus 2 is 14. 11 or 14, whichever is less. 11 is less. Here only one arrow, we got it. Now, here two arrows are busting. First of all, this one. 11 minus 8 is 3. Here two arrows are busting. So we need the minimum. 16 minus 5, 11. Or 3 minus 3, 0. Whichever is less. 0 is less. That's it. Now, critical path is the longest path from the first event to the last event, where EST, LFT values should be same. Here, this one is not same. So we have to go like this. 0, 0, 2, 3, 3, then 11, then 17, 24, then 33. Right? So in this way, this is the critical path. Critical path is always shown by double lines. Single line is non-critical. Double line is critical. Now we add up the project duration. The project duration are 3 plus 8 plus 6 plus 7 plus 9. So 3 plus 8 plus 6 plus 7 plus 9. It comes to 33. So total comes to 33 days. That's it. This is the end of problem number 13. Only critical path. Now see the problem number 14. Activity is composed of, a project is composed of 7 activities whose time estimates are listed in the table below. So activities are given 1 to 2, 1 to 3, 1 to 4 like that. Optimistic time TO, most likely time TM, and pessimistic time TP. The time is given in weeks. Again, we combine these 3 time estimates and calculate one expected time by applying the formula TO plus 4TM plus TP divided by 6. And what is the expected project length? Means project duration. And what is the probability that the project will be completed in at least 4 weeks earlier than expected time and no more than 4 weeks later than the expected time? So we need the probability. So when we need probability, we need variances. So first of all, we calculate expected time and variance. See here, calculation of expected time. Activities are given in the problem. TO, TM, TP, right? We need expected time TE and variance, sigma square. Already we know the formula 4 into TM plus TO plus TP divided by 6. So I have not written the formula. In the previous every formula I have written that formula. 4 TM, 4 into 1 is 4. 4 plus 1, 5. 5 plus 7, 12. 12 divided by 6 is 2. Got it. Then 4 into 4, 16. 16 plus 1, 17. 17 plus 7, 24. 24 divided by 6, 4. 2 4s are 8. 8 plus 2, 10. 10 plus 8, 18. 18 divided by 6, you will get 3. Like this, we have calculated expected time. And variance, TP minus TO divided by 6 whole square. So TP is how much? 7. 7 minus 1 is 6. 6 by 6 is 1. Square of 1 is 1. Similarly, 7 minus 1, 6. 6 by 6, 1. Square of 1 is 1. 8 minus 2 is 6. 6 by 6 is 1. 1 square is 1. 1 minus 1 is 0. 0 square is nothing but 0 only. 14 minus 2 is 12. 12 divided by 6 is 2. Square of 2 is 4. Like this, we have calculated the variance. Now we have to draw the diagram. The first activity, 1 to 2, 1 to 3, 1 to 4. 3 activities are bursting from event number 1. So here event number 1. 1 to 2, 1 to 3, 1 to 4. Right? Then 2 to 5, 3 to 5. 2 activities are merging at 5. So here I have taken 5. 2 to 5, 3 to 5. 2 activities are merging. Then 4 to 6, 5 to 6. 6th event. 4 to 6 and 5 to 6. Over diagram completed. Now write down the expected time of each activity. 1 to 2 activity 2. Here I have taken 2. Then 1 to 3 is 4. 1 to 3 is 4. Then 1 to 4 is 3. 1 to 4 is 3. So take all these expected time on the activities. Now we need EST value from the first event to the last event. Only one activity is merging. So 0 plus 2 is 2. 0 plus 4 is 4. 0 plus 3 is 3. Right? Now here 2 arrows are merging. So we take the maximum. 2 plus 1, 3 or 4 plus 6, 10. Whichever is higher. 10 is higher. Here 2 arrows are merging. Again we take the maximum. 10 plus 7, 17 or 3 plus 5, 8. Whichever is higher. 17 is higher. Forward pass completed. EST values calculated. Now LFT value. Backward pass. Deduct. 17 minus 7 is 10. 17 minus 5 is 12. Right? Then come to here. 10 minus 6 is 4. Right? Here 10 minus 1 is 9. Now we come to this one. 3 arrows are busting, so we need the minimum. 9 minus 2 is 7. 4 minus 4 is 0. 12 minus 3 is 9. Whichever is least. 4 minus 4 is 0. We got all the EST LFT value. Now longest path from first event to last event, critical path. This 312 and 29 are not critical. Both should be same, then only critical. So here 4, 4, 10, 10, 17, 17. So critical path goes from first event to third event, third to fifth, fifth to sixth. So critical path 1 to 3, 3 to 5, 5 to 6. And critical activities are 1 to 3, 3 to 5, 5 to 6. And duration of the project, add up 4 plus 6 plus 7, 17 weeks. Variance of the project. Take the variances of this critical activity. So 1 to 3 critical activity variance is 1. 1 to 3 critical activity. Then 3 to 5. 3 to 5 is 4. And 5 to 6. 5 to 6 is 4. Add up. 1 plus 4 plus 4, 9 is the variance. If you want standard deviation, root the variance. Root 9 is equal to 3. So the project duration is normally distributed with mean value 17 weeks. Where is that 17? Here. This duration normally, expected duration of completion is 17 weeks. And the standard deviation is 3 weeks. The standard normal variate is Z is equal to X minus mu divided by sigma. This is the formula for standard normal variate. This standard normal variate we require for calculating the probability. Now we'll attempt the second question, that is probability. Probability that the project is completed 4 weeks earlier. Normally expected duration is 17 weeks. What is the probability that it will be completed 4 weeks before 17? So 17 minus 4 comes to 13 weeks. What is the probability that the project will be completed in 13 weeks? So X is equal to 13. So in the formula, X is equal to 13. 13 minus 17 divided by 3, you will get minus 1.33. Right? Now, area from Z is equal to 0 to Z is equal to minus 1.33. This is the normal area curve. 0.5 area left side to this perpendicular and 0.5 to the right. But we need, what is the probability when X is less than 13 weeks? So mu is equal to 17, Z is equal to 0 in the middle. Now it is less, X is 13. 13 is less than 17. So left side. So here X is equal to 13. When X is equal to 13, what is the Z value we got? Minus 1.33. Now we need what is the area from Z is equal to 0 to Z is equal to 1.33. I already told you in the previous problem, you refer the normal area curve. Table value. Table value of normal area curve. In any textbook you'll get, or you refer the internet, you can be able to get the values of normal area curve. So under 1.3 and against 1.3 under 3. This is the normal area curve. So in this 1.3, we want minus 1.33. Actually, for locating this area values, area will always be positive. So see 1.3 under 3. So here it is 1.3. So under 3, you are getting 0.4082. 0.4082. So this area from Z is equal to 0 to Z is equal to 1.33, it is 0.4082. But we need the shaded area. What is the probability that the project will be completed within 30 weeks? Below 13 weeks, not more than 30 weeks. So we need this shaded area. So complete area to left side is 0.5. From 0.5, deduct 0.4082. So 0.5 minus 0.4082, the shaded area is 0.0918. So 0.0918 is the probability that the project will be completed in 13 weeks. In 13 weeks. The percentage terms 9.18%. 9.18% is the chance that the project will be completed 4 weeks before the expected time. The expected time is 17 weeks. That's it. Now last point. Probability that the project is completed no more than 4 weeks later than the expected time. What is the probability that the project will be completed 4 weeks, not more than 4 weeks later than the expected time? Expected time is 17 weeks. So 17 plus 4, 21 weeks. What is the probability that the project will be completed in 21 weeks? So X is equal to 21. We take x is equal to 21. So 21 minus 17 divided by 3, you are getting 1.33, positive 1.33. So z value will get negative 1.33 on left side of the curve. When we get positive value, it comes from the right side of the curve, 1.33. Now this is the curve I have drawn. Now x is equal to 21. 21 is more than 17. So in the middle, mu is equal to 17, z is equal to 0. So x is equal to 21. Here x was 13. 13 was less than 17. So left side. 21 is more than 17. So right side. When x is equal to 21, z is equal to 1.33. So if you refer the area table 1.3 under 3, you will get 0.4082. 0.4082. Now we need the complete shaded area. The left side, from the left side to the middle, it is 0.5. Already we know the total area under the normal curve is 1. 0.5 area left side and 0.5 area right side. So 0.5 is the left side area. And here from z is equal to 0 to z is equal to 1.3, 0.4082. Total area will be 0.5 plus 0.4082, 0.9082. So 90.82% is the probability that the project will be completed no more than 4 weeks beyond the expected time. That means, what is the probability that the project will be completed? 21 weeks is 90.82%. That's all. So this is the end of problem number 14. Totally 14 problems I have completed on network analysis. So if you are satisfied, give a like to the video, share my channel among your friends groups so that more students can watch the video. Give your comments. Subscribe my channel if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we'll continue the next problem in the next video.